Okay. Good evening to everybody. Thanks to be here. Just give a brief presentation on Enea, what it is, and what we do in the field of CCUS. Just give outline presentation, just some activities and three examples of technologies we play at Enea. So, Enea is the Italian national agency on new technologies, energy and sustainable economic development. The activities are targeted to research, innovation technology, and advanced services to public and private sector, and finally to citizens. We are about 2,600 people distributed into 12 research centers all over the Italian state. We particularly work in the field of energy and fossil fuel in the main themes on combustion, gasification and pyrolysis processes, CO2 capture, with solvent, solid solvent, oxy-fuel, different techniques. We also work on utilization of CO2. And finally, we have some experts that are working on advanced cycles, new gas turbines, and something like that. We have a different scale approach. We start from studies, computer and small scale, then come to laboratories, chemical, chemistry, physics, different things, and finally to plants. We are part of the Sulcis technological pole, together with Sotacarbo. This is why we are here. Starting from 2014, the Italian Ministry of Economics, formerly the Ministry of Industry, stated an agreement with the local government of Sardinia to set the Sulcis technological pole. The actuators are both Enea and Sotacarbo, and we work in a program of 10 years in activities that are related to demonstration and pilot plants, development of technologies related to carbon capture and storage, and also experimenting different techniques in the storage and monitoring of CO2. A dedicated state task force for joint activities has been set up. And the topics are, as I say, gasification, combustion, capture, but also communication and dissemination of results. This is summer school, is an example of this type of activity. Moreover, Enea work aids to promote activities, innovation, applied research, in general to the public. I give now just three examples of activities related to CCS. This is the one you have heard about different techniques in these days. This is an example, is a capture of CO2 made by solvents. This is done in the plants you already see in the last days. We have a gasification plant that can produce syngas coming from coal and biomasses. And we work on the syngas to act with the capture of CO2. We done it into a two-column plant. We have a solar column on the left, where the syngas is fed from the bottom, and meet the solvent that comes from the up of the tower. So the sweet gas can be delivered to atmosphere without CO2, while the rich solution is sent to the second column. It is a regeneration column. So what we do, we try to make experience on different packing columns, so I mean rings, saddles with different materials, metallic, ceramic. We make also different analysis into laboratories to characterize the solvent behavior, so measuring density, viscosity, pH, all things from chemical laboratory. And we stand different experiments, varying flows, concentrations, type of feedings, so different gases can be used. I mean, syngas, natural gas, gas coming from combustion of different things, but also mixing from cylinders. And we measure temperature, pressures, composition, and finally some calculation on efficiency, setup of a new design of components. Okay, this was for liquid solvents. This second example of activities. This is carbon capture on solvents. So in solid matter. This is done in Rome at Casaccia Research Center, where we work on the Zecomix process. This is a zero-emission carbon mix technology. Practically, we do some experimentation on calcium looping. We have on one side carbonator unit. We use calcium oxide to capture CO2. We use calcium oxide or materials, solid materials that are based on calcium oxide. We capture CO2 at high temperature to produce carbonates, calcium carbonates. And then in the second phase, in the second unit, we have the regeneration of this matter, this carbonate, to reproduct calcium oxide and strip CO2. This is done. We have also some side reaction that are steam reforming and water gas shift that enhance the production of hydrogen. So I have in the feeding a syngas that has hydrogen, CO, CO2, and at the outlet I have a gas with a high concentration of hydrogen. This is a picture of the plant. It's about 200 square meters of footprint. We have into the platform the different section. So the gasification section, the gasifier, a CO2 capture section is the carbonator. It's a fluid bed carbonator where the calcium oxide reacts with the syngas. We have a regeneration section, the calciner, where the carbonates are practically burnt to reproduct CO2. We have the power unit. It is a micro turbine in the scale of 100 kilowatts. And finally, a section for treatment of produced CO2. So, just to give some detail, we have a gasifier. It's about 300 kilowatts thermical. It's a bubble bed, fluidized bed. could be fed by a flow of about 50 kilograms per hour of coal or biomass. After, downstream, we have the carbonator. This is also a fluidized bed reactor. It can be loaded with a different solvent. We use dolomite, olivine as a medium. But we also made some experiments on catalyst added to the solvent. So I mean nickel base and other metallic catalysts. Power section, and we have a micro turbine. This is based on Tarbeck design. Can be fed with various fuels, including hydrogen. And we use it to perform different activities, also in fuel switching and changing the load fast in time. Okay, third example. It's about the production of synthetic natural gas. We see here different possible routes that deal from starting from coal, starting from biomass, passing through gasification, can reach different products. We study in particular the production of gas, so it's not similar to natural gas, by the methanation process. So we have different activities on that, starting from an experimental test on commercial catalyst. I mean nickel-based, ruthenium-based, for example. We have pilot scale testing and modeling activities and analysis from the economical point of view. And we have also project and coordination activities with external bodies like university and other foreign bodies. The process is based on gasification, then passes to clean up. We have methanation, so production of CH4, and finally polishing and compression. The SMG technology, as I said, is something that have CCS integrated into the process. So it's quite easy to think the two things together. Because removing part of the CO2 is mandatory to reach good specs of the gas if you have to send it to the national grid. So we have a small mobile plant, the name is Jessica. It's in the dimension of a 20 feet shippable container. And we have here a gasifier, different reactors, and some components also for treating and polishing the gas. So I mean scrubbers, membranes, filters, things like that. We make on that different experimentations, starting from gasification. We are now moving to downdraft configuration to start experimentation also with oxygen feeding to make higher energy content syngas. Okay, finally, something on power to gas. There's the possibility to progress out synthetic natural gas, also passing not from gasification, not directly, but using CO2 or gases with high content of CO2 that comes from other sources. One example is the already captured CO2 coming from industry, but also syngas, biogas, soy gas, and making that CO2 react with hydrogen that comes from electrolytic from electrolyzers. This could be a way we are studying it. So, conclusion. I give also some spots on Enea commitment in CCUS. There is no silver bullet technology that can solve all the problems. We study different things. So solvents, energy production, but there are also activity on membranes, oxy-fuel, fuel cells. The vision is to switch, starting from coal, then biomass, methane, hydrogen, to general lower carbon content fuels, up to renewables. So this is a good thing, a good vision for our sector maybe, but we have still some problem on energy intensive industry, so I mean cement production, steel, chemical, huge plants. So we still have to work a lot with CCS technologies. Costs are still high, efficiency still has to be increasing. Still there is a lot of work to do, and it's okay. Thank you. I don't know if there is time for one question, or maybe I have to start with the work of the groups. I don't know the organization, Amedeo and Alessandro. One question. Yes, olivine is one possible medium that is charged into the fluidized bed. It has also a catalytic activity and is used to enhance the conversion of the solids. And it's made from magnesium, it's the green stone. Used powder. It's powder that is charged into the bed. Yes, because strengthens the conversion of carbon dioxide in that case.
I have one question. Are you pursuing any oxy-conversion technologies?
Yes, we have some experts that work on that. They start with oxy-combustion of coal some years ago, with projects also with external companies like ITEA. Now this thing is in some way stopped. They are continuing it with a new attention to oxy-combustion of natural gas. So the idea is to work with pressurized system and recycling part of the CO2 to moderate temperature.
Okay. One question.
So the last, Sergio, because there is no time.
Sorry. No, I have been happy to see that you are involved also in storage of energy. I had the perception that this may be a very important issue in the future. If it is an important, the question is if it is playing an important role within Enea.
Yeah, this is a really important theme, especially for Europe, because we are to move every day more on renewable sources. So the point to have energy storage to couple in some way differences between demand and offer of energy is really important. In this case, the methanation is a special type of energy storage. We can think to batteries, capacitors, to there are many technologies, but that one is the one that can give some solution into really large scale energy storage. Put together some technologies that can be integrated with the CCS teams, and the problem is the cost of hydrogen. So there is a lot of work to do. Thank you, grazie.